Hello and welcome to this month's webinar, Pivoting to Success with a High Agility Database. Databases are not traditionally flexible. Relational databases almost actively resist modifications to their data structure, and even NoSQL databases tend to lock you into particular schemas. RavenDB does things differently. Today, RavenDB CEO Oren Aney will explain how RavenDB provides the flexibility to adapt your data to changing business needs and the scalability to grow with your success. Thank you for joining us. Please enjoy your webinar, and here's Oren.
Hi, thank you everyone for showing up for this webinar. I wanted to remind you, please, anytime that you have any questions, raise your hands or just cast it either in the chat or in voice. I would much rather have everyone ask questions as they're raised. Now, let's talk about some interesting problems with databases. One of the key issues with databases and agility is that, well, it's trivial to change your data model at the beginning. But how do you manage that over time? Especially if you're working in an agile system or working in an environment where you are dealing with long-lived systems. What's going on? How are you dealing with that? And the question is quite simple. Here is the first day on the job. You start by defining the shape of your data. What happens then? Well, this is the time where you know the least about your project, about what you will need. And at that point, something really interesting happens. This is what happens when you need to refactor. Now, consider this. I'm making a decision, pouring concrete at the very start of my project. And it's very hard for me to modify that after the fact. What am I going to end up with? I'm going to end up here, where I'm being actively prevented from making changes. Now, this can be a policy where you're actually being told explicitly, we cannot change the database. At one point, I had to watch where someone noted that, hey, this is the age field in the database is 32 bits int. And people only live to 120. That gives me 24 bits to play with. No need to change the schema. Just shoot your project maintainability in the head. Now, this is not a new problem. Absolutely not. And this is a really nice book. It was published close to 20 years ago, I think. 350 pages that tell you how you can deal with modifying databases. Now, there are two stages here that we have to consider. One of them is online modifications, where I have to modify how the system behaves on the fly with zero downtime. That's hard. However, there is another aspect here. What about when I'm just working, no read data yet? I'm free to make whatever modification that I want. Except that each of these modifications require me to do a whole bunch of work on my own. And that can be a killer for productivity and a significant barrier to change. So when we typically think about the issues of modifying databases, we typically think about this scenario. This is a scenario where you have to modify existing data while the system is running, maybe manage multiple concurrent versions of applications. But that's the easy part. That is something that you know you have to deal with. The actual problem is the barrier to the things that you have to change that aren't yet at this point. Because what it does, it ties you to existing early on design decisions. Because the cost of making that change is so high. Oh, I have to modify, I have to write the migration scripts. I have to write the data. I have to check it in. I have to set up a migration framework. About 15 years ago, I was really into the Hibernate object relational mapper. And in general, object relational mappers in the relational databases. And that was my day job. And one of the key aspects that was amazing was the notion of schema generation. The idea was quite simple. You start from working on your entity models. You define them, you process them, whatever you want. And then there was this magic command that you could run. Schema export that would go ahead, that would go ahead and create appropriate tables and indexes and relationship and whatnot in the database. And the impact that had on the agility of the system was absolutely amazing. Because even something as simple as adding a column, adding a new property on the model used to be a really painful process. You have to add it to the model, add it to the mapping, write the migration script up and down to make sure that everything works, and a whole bunch of other nonsense like that. Or you could just edit, have auto configuration, wire it all up, hit schema export, and you have a database with the right schema. Now, didn't quite work that well when we are talking about when we have actual data. But that was a significant boost to the ability to model and develop the system. And again, I don't have to pour concrete on the very first day. The other aspect that we have to deal with is how do we deal with existing data? And in this case, we have to consider whatever we are doing one-off or continuous process. A one-off process means that I have a set of data that I need to take and move to a different version, just one time, typically during a migration. Hopefully, this is an offline migration. So I shut down my application, migrate the data, migrate the shape of the data if necessary, and the next stage that I have to do is update the code, and now I'm up and running. That's the easiest model to work with. However, there are still impacts here. One of them is the time that you have to do this operation, which is a crucial impact. What do I mean? If you have a large data set, hundreds of gigabytes, which is now not an uncommon size, and you need to add a new column. In some databases, that can take hours. Literally, you have to modify the entire data and touch every single row in the table. In other databases, adding an index can lock the entire database down for a significant amount of time. That is, again, a huge barrier to change. And finally, and almost insidiously nasty, is the notion of optimizations. Everyone wants to have applications that run faster. That's pretty much that nice, good feeling that you get, oh, I optimize things and they're faster and everyone is happy with me. And I can go home and tell my family, hey, I made things 50% faster and now I hit my goal of performance targets, and I don't know, open a bottle of champagne. Now, what do you think is the impact of modifying the database on optimizations? Oh, you change a query? That's a problem. We have to go and analyze all of the impact that has. Oh, you added a column. Oh, that's scary. At one point, I saw a relatively trivial change. We add another a column to a query. It was something like from users where email equal X, and it should be where email equal X and ban equal false, or something like that. One of those query used an index. The other one did not. That meant that login time went from few dozens milliseconds to dozens of seconds, especially because we kicked everyone from the system, so everyone had to log in at the same time. It's a problem. Now, so what do? I mentioned that I spent a lot of time in the enablement and a lot of time in making sure that my process was streamlined. Once I start working on RavenDB, one of the key design goals was to bring it the same feeling of being able to change things, of being able to rapidly work with the system. In fact, one of the key design principles was that I don't need to meet the requirements that I had in enablement. I have to significantly exceed them. So how does it work? Well, to start with, RavenDB doesn't have a schema, which isn't actually an accurate statement. RavenDB has schema. That schema is the object model with which you're working with the database. So RavenDB is schemaless, but you typically work with some model, some classes that you define in your code in order to make it happen. Let me give you an example. This is the public dataset. And you can see here is some good example of model classes. Most of them are about as simple as we could make them. So what's the point? The point is that you define your code, you define your model, you have the ability to lean on refactoring tools. In the IDE, go hit F2, rename, it works. You want to create complex class hierarchies, it works. Everything is possible. Your code gets to decide what the shape of the data should be. And your code isn't some complex mapping, automap or something like that. It's just straight down definition, as simple as you can make it happen. Now, it's actually more interesting than that, because one of the impact of the decision is that the schema, the way that you talk to the database, the way that what you expect the database to be, is also versioned. So instead of having to create some sort of a versioning scheme or a versioning scheme for your schema, or you have to have some way of figuring out how to store the schema of your data, it's already built in directly into your code, which makes things a whole lot more simpler. Now, this is something quite important. It's your responsibility, is an abdication of responsibility from my perspective. That's not a good thing. Remember, the whole point of RavenDB was to make it easier. So we need to provide a solution for how you can manage your data, mutate the shape of the data over time, all of that. The fact that it's in source control in your code, it's great. But what happened when you change the data? You change the shape of the data. Let's talk about that. So this is the simplest thing. You have a class. properties. You can actually use the new record syntax, which is kind of cool. You can do something like this. And that's a record definition. That's sufficient for RavenDB to be able to properly work with it, serialize that, etc. Now, you can also work with dynamic data, and there's actually quite a few ways of doing that. Now, remember that there are two stages for modifying the data. The first stage is during early development. You probably don't have any data. If you have data, you're pulling that from some other sources, so you get to change everything as you wish, and everything else just adapts. That's probably and that's more or less by design, because at this point you have nothing valuable in the database, so you don't need to keep everything around. At this point, you can add, remove, modify, whatever, and the database works with you. Now, this is interesting because this applies both to working for the schema and working with that, but it also applies when we are talking about queries and other operations like that. Think about what this means. If you're using something like a link, strongly typed queries, everything is already done by the compiler. It verifies that your code is working and you didn't break anything, and that is a very powerful thing to lean on. Beyond that, it also means that you don't really have to consider, oh, do I have to have indexes here? Is this query optimal here? Stuff like that. Just write your queries, make everything happen as you wish it to be. And it's the responsibility of RavenDB to figure out what is the best outcome for your scenario. Now, as I mentioned, this is at the beginning of the project. At some point, however, you start to accumulate actual meaningful data. So we can't be just willy-nilly and change everything as we go along. Let's see what we can do. So the easiest thing that we might want to do is just let's add a new property. You can see it here, favorite color. Now, this is a really interesting operation that I just made here, because I made a modification in my code. So nothing actually changed in the database. Now, let's talk about what is the impact here. If I'm loading a user document, well, it doesn't have a favorite color. So the instance just loaded will get the default that was defined in the class definition. In this case, it would be orange. If I'm looking at the data in the database, there is no favorite color property. So in the database, nothing is changed. In your object model, it is changed. You might need to consider that for queries, but in most cases, if you don't need to query for the missing property, just need, oh, I need it to be here, easy enough to do. Now, that actually leads to an interesting problem. What happens if I have to work with a mixed version system? So version 1 of this system doesn't have a favorite color. Version 2 does. How is it going to work when I have both versions running in parallel on the same dataset, on the same database? Well, as it turns out, we thought about that. And this is a feature that almost no one knows that we have, and I'm really proud of that. Because if you load a RavenDB instance, RavenDB document that has the favorite color property, in a version that doesn't have the favorite color property, well, we don't run error. We don't do anything. We just give you the old version of the document, which this is what you can deserialize it to. However, we remember that we have a property that you didn't see. When you save the modified data back, we will return that value back. So that value would be persistent. In effect, it would be invisible passenger on the V1 version. Now, conversely, what happens if I need to remove a property? Well, this is just like the V1 to V2 version, but in reverse. Now I have a property on the existing documents. That property does not exist in my model, so it doesn't get deserialized, but it still persisted even when I modify the data. And that feature is actually there for two reasons. One of them is specifically for the versioning, but the other one is what happens if I messed up and accidentally change a property name. In that case, I didn't modify the data. All of the existing documents are still there, haven't modified, and I can just revert my code change and everything will go back the way it was. And it actually was quite helpful for us several times. Now, those are the simplest things. Let's talk about something slightly more complex. We used to have a user that has a phone number. Now we need to make it into a user that has phone numbers. Well, that turns out to be quite easy. Notice that I'm writing code in my code. I don't need to write anything for the database. And I'm leaning on the fact that the deserializer is going to call the properties. So the backing store of the phone property is the first element in the phones. That's about it. And everything works from here, which is, if you consider that, really, really nice feature. Now, the nice thing about that, if you have an index on phone or queries on phone, that still works. Yeah, the phone number would be duplicate in the record, but you probably don't care about that. And if you care about the storage space, you can enable document compression, and that would be completely removed. So this is a nice feature and a compatible change. And again, the whole point is that I can make that in my code. And that's something that you will see a lot. One of the things that happen a lot with data is that you have guardians showing up. And every change in the database has to go through 10 different departments and gatekeepers and things like that. RavenDB was designed to be an application database. It is rare for RavenDB to be a shared database for an organization. It is typically strongly bounded to a particular database. What this means in turn is that RavenDB can make assumptions. Oh, the people who are using me are not going to need all of those change process and things like that. I want to make this easy for them. So a lot of that is I want to push as much as possible directly into your code, because most of the people working with RavenDB are developers, and we want to make sure that they are operating in the most comfortable environment for them, which is their IDE, and not into, oh, I love the RavenDB Studio. I think it's amazing. But as a developer, give me code. That's the easiest thing to do instead of, oh, I have to do something else, etc. Now, sidebar. quite important. Even though RavenDB is persistent, a lot of the time we're trying to give you the feeling that, oh, you can just operate on things just like you're working with in-memory data. And again, going back to my days working on enablement and object relational mappers, one of the primary issues was the notion of impedance mismatch, that we had such a huge difference between how the database model the data, how you work with data at the database level, and how you work with the data at the application level. So RavenDB does as simple as possible serialization of your data. An entity is a document, which can be as arbitrarily complex as you want. It is your responsibility to model the data, hopefully using something like domain-driven design that gives you clear boundaries and make it quite easy to work with the system. And the end result is that we enable you to work in a far more rapid and agile manner. So let's talk about data versioning. What happens if I have existing data and I need to modify the shape? I already talked about a couple of compatible versions, but we have to make an important distinction. RavenDB doesn't actually care about the shape of data. For the point of view of RavenDB, you give it JSON documents. How you serialize or deserialize that on the client side, that's your responsibility, your concern. The server doesn't care. The client does, and we also write the client, so we do care. So your code care about the shape of the data. So what happens when you load something that has missing property? You added the phone's property, and a particular document doesn't have that. Well, let's go back here and see. But I notice that here we probably have to do a new here. Otherwise, this would throw an array. But beyond that, it would work. So the code has to accept that some information might be missing if it's old. Now, sometimes you cannot make that assumption. That's when we have the notion of active migration. And you can do a patch by query. And you can see the query here. This is how we do the migration from font to fonts. From font to fonts, sorry. So here is an interesting observation here. First of all, this is not a compatible change. We are deleting the font property. That depends on what sort of migration you have. This sort of script is applicable if you're running on an offline model. I'm shutting down the system, migrating the data, starting the system again. On the other hand, you may want to do something like this and run it and not delete the font property. So maybe do it in 2 stages. In some cases, you don't need to modify the data, but may not modify the shape of the data, but the content of the data. For example, you may have missed, I have a full name property, I have to do some other things, whatever. Doesn't actually matter this much. But if you are running those sort of queries, those sort of operations in your system, one of the things that you have to be aware of is the cost of doing that. If I have 10 million users, this query is going to change 10 million users, and that's going to run as fast as I will let it happen. In many cases, that would be tens of thousands of modifications per second. That's kind of expensive. If I'm running in the cloud, I may be burning through all of my IO credits. So you can actually put a limit that says, hey, you know what? I want this to run at a rate of 100 per second because I explicitly wanted to take more time to not impact overall operations. Now, let's talk about queries. Queries are, well, basically, you ask RavenDB some questions, and it gives you some results back. Now, the interesting thing about that is how does it work? RavenDB uses indexes, pretty much all databases do. And we have to consider what sort of indexes do we want to use. You can either use auto indexes, which basically means I'm just going to query the data, and the RavenDB query optimizer is responsible for managing the indexes for me. I don't need to worry about that. On the other hand, I can define static indexes that I write myself. And in those cases, I have to worry about versioning, things like that. Otherwise, RavenDB will just handle that for me. Now, this matters because for the best case scenario, I want to use I want to do the minimum amount of work when I'm changing my system. So the easiest thing to do here is to use dynamic queries, and let RavenDB handle that. RavenDB is in charge of all of the optimizations. Now, that leads to an interesting problem. If I'm deploying a new version to production, I probably change how my system behaves. Now, in general, that's not a problem. RavenDB will be able to learn from the operation that you're making, optimize itself accordingly. Perfect, right? Almost. There is still an issue here. If you do that in production, there is a period of time where RavenDB is still learning. That kind of sucks. Well, the interesting point here, you don't have to make that in production. You can run a test environment, run whatever use cases you have there, and teach RavenDB how the new system behaves. And then you can take that system, that knowledge, and push that to production. So before you apply your new version, before you deploy a new version to production, you take the knowledge of, oh, this is how the system is going to behave, and push that to the production system, where RavenDB will apply that to generate the appropriate indexes, do whatever needs to be done. Once you apply your system, it's ready. RavenDB already know how you expect it to behave. So as much as I like dynamic indexes, what about if I have to use static indexes? A lot of the more complex features in RavenDB, MapReduce, recursive MapReduce, all sorts of complex indexes require you to use static indexes. So how does that work? Well, indexes are sort of like a schema, but we have to consider how they're used. First of all, by default, the recommended approach is to use something like abstract index creation task. In all of the RavenDB clients, you can define your indexes as part of your code. You have some variant of index creation, which is a class that scans your assembly, your package, whatever you're using, and generate the appropriate indexes. So you don't really have to think about that. For development, I recommend that every time that your application starts, just go ahead and create indexes. That gives you the best option for not really thinking about that. Sorry. Not really having to think about indexes. You write your index in your code, you hit F5, everything is running, the index is done. For production, you probably want to have better gatekeeping. But that leads to an interesting set of features. RavenDB know that indexes, especially on large data sets, can be expensive, creating indexes. Therefore, we actually have a set of features specifically for that. One of them is side-by-side indexes. Side-by-side indexes allow RavenDB to create a new version of an index while the old one is still in operation, still index new data. And the new version of the index is going to run alongside it, not process any query, but process all of the documents that match that particular index. Once that index has completed, we can atomically switch between those indexes. The idea here is, let's say that I have 100 gigabytes of data and deploying a new index takes me 2 hours. During these 2 hours, I still have data being modified, all of those sort of things. I don't want to stop for a significant amount of time. I want to deploy the index and move on with my life. This is what side-by-side index allows me to do. In addition to that, we also have the notion of rolling index deployment. This is a new feature in 5.2, I think. And these features allow me to basically say, okay, I'm deploying an index on one node at a time. The idea here is that we typically use that on the least busy node, so we don't get into a position where, oh, I just deployed a new index that's incredibly expensive in terms of I/O, CPU, whatever, and that takes all of the processing power of the cluster. Instead, okay, this node is now deploying that, this node is deploying that, etc. And again, the whole idea is that we can deploy something in the background safely and easily. So let's talk about what sort of changes I can make for indexes. Again, we have this notion of compatible changes. Adding fields, storing a field, those sort of things, you can make that. That's easy. You deploy it up front. It goes with side-by-side. You can do with rolling deployment. You can do side-by-side and rolling, by the way. All of the old code still work, nothing changes. Once you deploy a new version that uses the new capability of the index, you're good. However, sometimes you have to make modifications that are not so easy. At that point, the recommendation is to use a naming scheme. User search /2/3, etc. And the idea here is that you're bound to a particular version. In this case, the deployment model is slightly more complex. You deploy the new indexes, let them run. Then you deploy the new code. Then you undeploy all of the old code that is still using the old indexes, and only then you can delete them. The downside of this approach is that you may have more indexes that are strictly required. But the whole idea here is that we want to reduce as much as possible the amount of work that you actually have to do to manage that. And trading off additional computation resources for the developer time is usually a much better trade-off. Subscriptions are also something that you have to think about modifications. A subscription is a persistent query. What happens when you change the subscription query? For example, I may have a subscription, give me all of the new employees in London. And at some point I realize, hey, I don't actually need all of the new employees in London. I need all of the employees in London that wear glasses. So what happens then? I can modify the persistent query at every point in time. And it will apply only to documents that I haven't seen yet. I can also decide when I'm modifying or creating a subscription from which point in time it should begin. Beginning of time, the last documents, only new documents, a particular document, and onward and stuff like that. RavenDB also has the feature called version subscriptions. In this case, you're going to get the same, you're going to get a tuple of the previous and current version of all of the changes that happened to the matching documents. Now, this is important because you have to realize that in this case, you have to think about the schema over time. It is possible you will, let's go back to the fonts example on the users. A revision is immutable. You cannot change that. So you have to be aware that, oh, maybe I will get a user that doesn't have a fonts field. It has a font field. So something to be aware of. In general, by the way, you can do those sort of changes in the subscription projections and operate on that. And with that, now is the time for questions. While we're waiting for questions, I want to remind you that you can use RavenDB freely, especially if you run on the cloud. We have a free instance that you can just start running. And you can also discover a lot of the cool things that we have in RavenDB if you go to the live demo. We schedule a session with one of our developer advocates to help you answer any questions that you have, etc. Do you have any questions? So that's great. I think I answered all of the questions that people had. Thank you very much and see you next time. Bye-bye.